Hello everyone, and welcome to today's presentation. I'm excited to have you here. Today we'll be exploring Newton's first law, also known as the law of inertia. On this first slide, we're introducing the core idea that an object at rest will stay at rest, and an object in motion will keep moving in a straight line at a constant speed, unless a force acts on it. Over the next few slides, we'll dive deeper into how this works and what it means for understanding motion. Let's get started. Let's take a closer look at Newton's second law of motion. This law tells us that the acceleration of an object depends on two main factors, the net force acting on it and its mass. Essentially, the harder you push or pull, the faster an object will accelerate, but how much it accelerates also depends on how heavy it is. This relationship is beautifully summarized by the equation F equals m times a here. F stands for force, which we measure in newtons. M is the mass of the object, measured in kilograms, and A is the acceleration, which is expressed in meters per second squared. What this means practically is that if you apply a larger force to an object, its acceleration increases. So, a stronger push results in a quicker change in speed. On the other hand, if the object is heavier, having more mass, you'll need to exert a greater force to achieve the same acceleration. This principle is fundamental because it helps us understand how forces influence motion in everyday life, from pushing a shopping cart to launching rockets into space. It ties directly into our overall theme of understanding the laws that govern movement and how we can predict and control it. All right, let's talk about Newton's third law. It states that for every action, there is an equal and opposite reaction. What does that mean in simple terms? Well, whenever one object applies a force to a second object, the second object responds by applying a force back. And importantly, this force is equal in strength, but acts in the exact opposite direction. So if you push on a wall, the wall pushes back with the same force on you. This principle is fundamental because it explains how interactions happen in the physical world. It connects to everything from how rockets launch into space to how we walk, or even how objects stay in place. It's all about the balance of forces, and understanding this helps us see the underlying mechanics of motion and interaction around us. Let's look at some real-world examples that illustrate the concepts we've been discussing. These examples help us see how theory translates into practice and highlight the practical applications of what we've learned. By examining these cases, we can better understand the impact and relevance of these ideas in everyday situations. As we go through these examples, keep in mind how they connect to the broader themes of innovation and problem-solving that we've been exploring. This connection really underscores the importance of applying these principles thoughtfully in various contexts. Thank you so much for your time and attention today. I really appreciate your interest in the topic we've discussed. Remember, the key points we covered highlight the importance of understanding the core concepts and how they connect to the bigger picture. This knowledge can truly make a difference in your work and decision-making processes. If you have any questions later, please don't hesitate to reach out. Once again, thank you for being here and for your engagement throughout the presentation.